Welcome to Mickey Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement for creating these kinds of technical videos and published in a public domain like YouTube. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for igniting me such kind of a crux to create these kinds of technical videos in a public domain, and his uh, continuous support and encouragement. And I would like to thank my almighty for my good health and broad mind. And I would like to thank my friends, followers, my dear students and subscribers. Today's topic of interest is gear train. What is meant by a gear train? It simply we can call it as a gear train is comprises of a driver and a driven. It comprises of a driver and driven. Okay, whenever a power is transmitted from one gear to another gear in terms of a torque or a speed, we simply call it as a simple gear train. If there is a intermittent gear If there is an intermittent gear is there, that is also called as a simple gear train. If in a single shaft more than one gear is mounted, it is called as a compound gear train. Here I would like to give an example that if you having an opportunity of open an engine, if the starter motor cranks the flywheel, it is a simple gear train. Okay, if the starter motor cranks the flywheel, it is a simple gear train. In 2 decades before, instead of timing chain, we are using timing gears. That is a simple gear train because a driver gear is in the crank and the driven gear is in the cam. Therefore, only two gears are motored and there is a power transmission like the crankshaft is rotating at 1000 rpm, the camshaft is supposed to be run at the 500 rpm, therefore speed reduction is there, therefore more torque is given to the camshaft, so it is a simple gear train. In the same automobile, if you have an opportunity to open a gearbox, it is a compound gear train. How? The driver gear is mounted and the driven gear is mounted by means of a lay shaft, and more than one number of gears are coupled in a single shaft. There is only one driver shaft and only one driven shaft. Both are coaxial. Whereas the power is transmitted from the drive drive gear to the driven gears by means of a lay shaft, so it is called as a compound gear train. There is also a the power and the speed can be manipulated. So the main purpose of the gear train is in order to manipulate the power as well as the torque or a speed and torque. We know the relation the power is directly proportional to speed and torque. The power is directly proportional to speed and torque, whereas the torque and speed are inversely proportionals. If you want to give more torque, then the driven wheel should be rotated at a very small speed or a very low speed. If you want to create more speed means there is no torque. So in a same automobile, if you are putting a first gear, the torque is huge, whereas speed is very low. If you are put a top gear or a fourth or fifth gear, the speed is huge where the torque is very less. So that is the purpose of the gear train. Here we would like to introduce the gear train with the simple gear train. That is, it having only driver and driven in the gear train drive. The distance between two wheels are greater. If the distance between two wheels are greater, by providing a large size of wheel or by providing one or more intermittent gears, the simple gear train can be achieved. If the intermittent wheels are in odd in motion, okay, if I am saying there is a driver and driver in between, I am having a single gear. What is that? It means that the intermittent is an odd one, 1, 3, 5, 7, 9, like kind of a gears are called as an odd number of gears. Therefore, if the driver and driven are in like motion, if the intermittent gear is an odd gear, then the driver and driven is in same motion, same like motion. If I say the driver is in clockwise direction, the driven is also in the clockwise direction. If I am saying in the intermittent gears having even number of teeth, that is 2, 4, 6, 8, like that, the motion is unlike. What it means that the motion of the follower will be opposite to the direction of driven. If I say driver is clockwise direction, in the even number of simple gear train, the driven is in the anti-clockwise direction. So that is our understanding about the simple gear train. Here, the simple gear train is governed by an equation, that is, as per the law of gearing, N2 by N1 is equal to T1 by T2, which is equal to D1 by D2. Here, D1 and D2 are the pitch circle diameter of the driver and driven. T1 and T2 are the number of teeth available in driver and driven, where N1 and N2 are the speed of the driver and driven. Here, let's we go with the compounded gear train. Compounded gear train is, as I said earlier, in a single shaft more than one number of gear is mounted. Here, the train value is the very important one. Where the simple gear train, so this is the train value. So the ratio of speed and the number of teeth is called as a train value. And the compounded gear train, the train value is speed of the last follower divided by speed of the first driver, which is equal to product of teeth of the drivers divided by product of teeth of the followers. Here what I say is, if I am having 6 gear train, if N6 by N1 is the train ratio, if it is the train ratio, which is equal to T1, T3, T5, these are the drivers, and T2, T4, T6 are the followers. Okay, let me draw that how it will be look like. If this is my driver and here is the driven. In the driven, we can mount with a huge driver and it drives in another gear. And it also having a huge gear. This gear will drive in another follower. Like that, if this is the driver, 1 is the driver, then 2 is the follower, and 3 again it goes to the driver, and 4 is the follower, and 5 is the driver, and 6 is the follower. Therefore, this is a simple compounded gear train. simple compounded gear train, whereas 1 and 6 are driver and driven. These driver and driven are coupled by means of a compounded gear set of 2 and 3 and 4 and 5. So this is our understanding. Next is the riveted gear train. Riveted gear train, which is the axis of the first and last wheel are coaxial. This train is known as riveted gear train. The riveted gear train are used in watch mechanism, automobile transmission, lathe tumbler gears are their applications of riveted gear train. Next one is the epicyclic gear train. In the epicyclic gear train, in all the automated gearboxes are using epicyclic gear train, as well as in the differential of any vehicle. If a vehicle having differential, it is supposed to be run at epicyclic gear train. Okay, the epicyclic gear train, when the gear train or a simple gear train is coupled with an arm, where gear wheel is rotating about the axis of the wheel, where the either arm can rotate or also A can rotate. If I am saying if my arm is fixed, what will happen? It is rotating, B is rotating, simply A is rotating. It will become a simple gear train. If I say if my gear B is fixed, what will happen? The C rotates and the A, it rotate by itself as well as it rotate B. It will come around the B. So it is one type of a inversion of an elliptical gear train. If I am saying if A is fixed, what will happen? If the C will revolve as well as B, it will rotate by itself as well as revolve. What is the difference between the previous case is, if the gear B is large and gear A is small, it produces more speed. If the gear B is fixed, that gear train produces huge speed. If A is fixed, A is a smaller in diameter, therefore, and B is the huge diameter, therefore speed is reduced and torque is more. By this method only, the simple gear train gearboxes, automated gearboxes, with a single set of a planetary gear set, they are producing a different kinds of a speeds. So this is our understanding about the elliptical gear train. Here we have a four types of conditions, where the last condition is very important. As I said earlier, the inversions. First, the arm is fixed. Wheel A rotates through one revolution, that is one revolution in anti-clockwise direction. Arm rotation is 0. Wheel A is +1 rotation. Wheel B, according to the teeth, it will give an anti-clockwise direction. That is why here the minus symbol is indicated. If the arm is fixed, if the wheel rotates x revolution, what happens? The arm C is 0, whereas A is in positive x direction. That means wheel B is having negative x into the train value. If positive y revolution of all element is done, if all elements are rotating, then all are having plus positive y revolution. That means what the input, the same input is given to the output. So this is the fourth condition. There is none of the A, B, C is fixed. What will happen? Whatever may be the driver revolves as the same, the driven is also revolves. Arm C is revolving the same velocity, and the wheel A is rotating in the same velocity, wheel B is rotating in the same velocity. Here the total motion is, if arm C is having plus y and wheel is having x plus y in same direction, where wheel B is having y minus x into the train value. So this is the by this method the different kinds of the speeds are achieved by means of the elliptical epicyclic gear train. So that is all about today's lecture. I hope you have all enjoyed the session. I hope that I am giving enough knowledge transfer about the gear train. I would like to thank you all for your patient listening. And if you have any doubts, please let me know in the comment section. Thank you.